Hi everyone, welcome again to the world of Agentic AI system. My name is Sam, and in this module I'm diving into the Agentic RAG system. So unlike this basic RAG system that just follow some specific instruction, Agentic RAG can make decision on its own, adapt its approach based on the situation, and handle complex tasks intelligently. So let's dive in to this interesting technology together. So we all know that today's world is overflown with information. So we have endless email, report, and online content at our fingertips. But having all this data is not a problem. The real problem is more around finding the important information when we need it. So we have all these regular search engines like Google that try to help us, but they are not perfect. They mostly look for matching words, which means they sometimes miss what we are really looking for. So it's like trying to find a specific shirt in an overstuffed closet that keep also getting bigger and bigger every day. This is where a RAG system or Retrieval Augmented Generation system is so exciting. It's a technology that does two specific things. Firstly, it finds the right information through element named retrieval part, and then based on those information, it actually just makes sense of it and generate the output. So instead of just showing some random search result, RAG try to understand what you are asking, and then based on that, give the relevant answer. So RAG, as I mentioned, is just a blend of two complementary forces, which are the retrieval part and also the generation part. So usually we have these large language model like GPT, which brings this ability to generate natural, insightful response through that generator element. And while we have like this retrieval element that can ensure the responses are grounded in the latest and most relevant data. So it's more like a kind of journalist researching a complex topic. So they need to be up to date and also pair that data with the contextual understanding. So that's where the way that RAG is operating. So this is the architecture of a basic RAG system. As you can see, there are like three main elements in this system. So we have the retrieval part, the generator part, which is more like a kind of large language model, and also this knowledge source. So whenever there is a query from the user, the retriever element try to use that query and find relevant document and relevant data from the knowledge source, and then it tries to just add that context to the query and then ask the generator part or the model to generate the response to the user. But like any other new technology, so these basic RAG system, they're not perfect. So there are like a number of main challenges with implementation of the basic RAG system. So the very first thing is about they can get overwhelmed by big or complex tasks. So imagine asking someone to quickly find a specific rule in a 500-page legal document. So they might get confused or even like sometimes miss important details. The basic RAG system also struggle with the tasks that need multiple steps. So for example, if you ask the RAG system to find some information and then compare it with something else, these types of system might just do the very first part and then ignore the rest of steps. So these systems also are not very flexible. So if you try to add new sources, or if you want to change how the whole system should work, it can be difficult. And then that's going to be very complex for those systems. So all these systems show that just a basic RAG system is not helpful, and especially for the complex task, we need the better solution and better technology. And that's where Agentic RAG comes into play to address those limitations of a basic RAG system. So you can think of basic RAG like more like a kind of library assistant who can only follow exact instruction. Now you can have like this agentic RAG system, which is a smart research partner who can think for themselves and then adjust their approach as needed. So there are like some key difference between these two systems. The very first difference comes the way that they work. So basic RAG system just follow the same steps every time, like a robot follow a script. But then agentic RAG system think and adjust on the fly. So more like a kind of detective following the leads. Also, in terms of making decision, basic RAG system need specific instruction for everything. But then agentic RAG can decide the best way to find information on its own. So these two key differences make agentic RAG especially useful when it comes to complex tasks where you actually need like very smart, flexible thinking rather than just following a set of instruction and processes. Now let's talk about the RAG architecture and the key elements of a RAG system. So at the heart of the agentic RAG system are all these intelligent agents. So these are like more like a modular entities that designed to perform a specific task and make the decision autonomously. So you can think of them as a specialist in a very well coordinated team. So each one responsible for a distinct role, but collaboration seamlessly to achieve a common goal. So the way that they are actually working, so you can consider agent that like you can have like a kind of agent that analyze user queries and then determine the best strategies for information retrieval and generation, and then adapt dynamically as the task evolves. So for example, one agent may just focus on the retrieving data, while another synthesize the information into a cohesive response. Also, each agent is equipped with the reasoning capabilities which enable them to tackle complex tasks through iterative steps. So for instance, we have like a specific type of agent named React, which is more like a kind of reasoning plus actioning, which evaluate the task, identify required tools, and even like retrieve relevant data and then decide on the next course of action. So we have like a kind of some information about this specific agent in the upcoming slides. The second component of the agentic RAG architecture, like the basic RAG system, is knowledge source, which serves the foundational data repository for the whole system. So these knowledge sources can include structured data like databases or even like some unstructured data from document, website, and more. So the knowledge sources provide that raw information or raw material that agent needs in order to generate meaningful responses. The third component of the agentic RAG system are these LLMs like GPT, which are the generative core of the agentic RAG system. They convert all these raw data from the knowledge sources into a coherent context-aware output tailored to the user queries. So all these LLMs interpret the user input, generate text, and then facilitate that natural conversation that is needed for the agentic system. The last but not least, we got these tools within the agentic RAG system, which allow agent to perform advanced action such as querying the database, scheduling appointment, or even conducting calculation. So they act actually as a medium between the system and the outside world. So example of tools can be like API tools, like Google Calendar API for scheduling, or some other kind of like tools that provide that API interaction that is needed for an agent. Or you can think of tools as more like a kind of custom utilities, like SQL engines or a script for data manipulation and extraction. By integrating tools to the whole system, agentic RAG system can seamlessly interact with the external environment and make those agentic system highly capable. So, and then the rest of the success of agentic RAG system lies in the collaboration among all these four key components. So agent act as a strategist, orchestrating the workflow and also ensuring the task execution is optimal. Then the knowledge source provide the raw data that agent needs for informed decision making. LLM to transform data into a meaningful human readable responses, and then tools to empower agent to extend their reach into a specialized action and even external system. So in terms of like the roles and responsibility of the agent in the RAG pipeline, there are three main areas that agent can support the RAG pipeline. So we may have like agents more like a kind of a specialized unit. So the agent operate as a modular task-specific entities within the pipeline. So each agent is designed to handle a particular aspect of the RAG workflow. So this modular approach actually enhances the flexibility of the whole RAG system. So for example, if you can add or replace the agent as needed without overhauling the whole entire system, so make that whole system adaptable to various tasks and domains. The second aspect of using agent within the RAG pipeline is around the collaboration for optimization. So while each agent is specialized, the true power of the whole pipeline lies in the collaboration. So agent coordinates their effort to ensure the efficiency and accuracy of the whole operation. So this collaboration ensures that the tasks are not duplicated or even like overlooked. So for example, a retrieval agent fetch the data and then pass it to the next agent, which can be like a summarization agent, which can then refine the output for the generation agent. So these collaboration process minimize the redundancies and also maximize precision, resulting in high quality response tailored to the user needs and queries. And then another aspect is more around the orchestration part. So effective orchestration is the glue that binds the agent together, and which can help to synchronize the task to create a seamless flow of information through the whole pipeline. So orchestration acts like a conductor in an orchestra. So it actually ensures that each agent knows when to act, how to share output, and then how to adapt to changing needs. So by operating, all these agents, by operating as a specialized unit, collaborating for optimal performance, and also functioning within a well-orchestrated system, they can transform complex tasks into an efficient and accurate process. And then this whole dynamic framework can make the backbone of the modern RAG system. Now let's talk about some of these popular types of agent that you may see in an agentic RAG system. So the very first one is a routing agent. So routing agent function like a traffic controller. So it actually analyzes the nature of the user queries and then direct them to the right pipeline. For example, a query asking for a document summary would be routed differently than query asking for a specific data insight. So you can think of it as visiting a hospital, right? So when you go to the receptionist, the receptionist acts as a routing agent and decide whether you need to see a general practitioner or a specialist or even like emergency care. So this targeted approach ensures that queries are handled efficiently and also accurately. The next type of agent that you may see is the query planning agent. So always complex queries often requires a divide and conquer approach. And query planning agent deconstruct the question like compare market trade for two industries over the last decade into a smaller task. So it can one task can be like retrieving data for each industry. Another task could be the analyzing the trend within each industry and then combining the result. So this modular approach enables to present a cohesive picture to the user and generate effective responses. Another type of agent that I mentioned before, the React or agent that use both reasoning and actioning. So React agent So especially when you are dealing with a multiple step dynamic task, these types of agent can help. So for example, consider planning a trip where you need to have the flight option, hotel recommendation, and even weather forecast. So React agent in such a situation can handle all these different aspects of the task by reasoning through each step. So it actually remember past action and then adapt as the new information become available. So this whole iterative process of reasoning and actioning ensure a comprehensive and accurate response to be generated to the user. Another type of agent is dynamic planning and execution agent. So these types of agent bring the long-term vision to the RAG system. So unlike the React agent that work step by step, these types of agent take a different approach. So they create a comprehensive plan before diving into the execution. So for example, for planning a corporate event, usually it involves multiple parallel tasks, things like booking a venue, arranging catering, and even like scheduling the speakers. So dynamic planning agent manage this complexity efficiently by outlining and executing each task, ensuring nothing falls through the cracks. All right, so we understand the basic RAG system, its challenges, and also the way that the Agentic RAG can help, its architecture, and some of popular types of agent that you may see in the Agentic RAG system. Now let's talk about the implementation. So there are like a number of frameworks that is out there that you can use to build Agentic RAG system. So these are like some of the popular ones, like Llama Index, which actually simplifies the process of managing and querying the data set from the large knowledge sources, or even like LangChain that can help to link multiple tasks seamlessly and create a workflow, and that can tackle complex queries step by step. So these are like some frameworks. I'm sure like there are like number of others that you can leverage to just build Agentic RAG system. But to help you better understand these types of agentic system, let's just quickly go through like an implementation of a very simple Agentic RAG system using LangChain framework. So the aim of this demonstration is to just help you how a collaborative multi-agent RAG system can help to retrieve, analyze, and even generate actionable insight. So as you can see here, the system that we are going to build includes three main types of agent. So we have a retrieval agent, analysis agent, and also the response generation agent. And the use case that we are going to go through is just more like a kind of customer feedback sentiment analysis. And then the user provide the query, the retrieval agent get that relevant feedbacks, and then pass it to like a sentiment analysis agent. And then that agent provide that sentiment output, and then give it to the response generation agent to use that sentiment and then generate a response to the user. So let's quickly go through how you can implement this using LangChain framework. So for the LangChain framework, the very first step is to just build that knowledge base. So let's say all the customer feedback are in this file as customer feedback.txt, and then we just load that data and then push it to this vector database so that we can later on use and also retrieve the relevant information that is needed. So the first step is, as I said, is to just set up the knowledge base. And then the next step is, again, using LangChain framework to just set up the retrieval agent, which tries the role of this agent is to just find the most relevant feedback based on the query that is provided to the system. The next agent is the analysis agent or sentiment analysis agent, which extract the sentiment or key trend from the retrieve feedback. And it's very simple. So we are just using this prompt template strategy to build that agent, and then defining that in the LangChain is very easy through this LLM chain that you can use. And then setting up the last agent, which is going to be used to generate the response. So again, the same process. And then we provide that prompt to be used to build that agent, and then here it's just this agent is going to help us to synthesize the analysis result and into a more like a kind of user-friendly response to be generated for the user. And now putting all those together as like a kind of workflow. So we have the query, and then we get that query, and then the retrieval part actually just help us to just find, based on this query, find the relevant customer feedback. And then that retrieved data is passed to the next agent, and then that next agent use that retrieved data to identify the sentiment related to that specific query, and then also the relevant customer feedback. And then lastly, the last agent is just use that sentiment analysis result to generate the final result to the user. So this is more like a kind of very simple example of how you can build a agentic RAG system using the LangChain framework. Now let's also quickly touch on the challenges and also key consideration that you need to have when you are building any sort of agentic RAG system. So the very first things that you need to consider is the data quality. So the old saying always say, garbage in, garbage out. And this is also especially true for agentic RAG system. So the quality of the data and also the quality of the generated output of this system directly depends on the quality of the data. So if your data set is incomplete or noisy, even the smartest agent can generate irrelevant data to the user. So you need to implement the rigorous process and practices to ensure the data is accurate, complete, and relevant, and then use that as part of your agentic system development and operation process. The next thing that you need to consider is the importance of explainability. So we all know a black box system is hard to trust, especially when it comes to the decisioning, right? And then for the agentic RAG system, the same things need to happen. So user need to understand not just the what, but also why behind agent decision. So transparency need to be developed to build that level of confidence to the user. So, and then you need to design this system that even like sometimes explain the reasoning. So for instance, you need to provide that a step-by-step breakdown of how agent arrive at conclusion so that you can build that trust with the user. So privacy and security concern is another things that you need to also consider. So RAG system often work with sensitive information. So as you saw in the architecture, we usually deal with the knowledge source, and those knowledge source may include sensitive information like personal data. And then any break in those types of data is going to be challenging. So you need to employ techniques like encryption, access control, and all those things to make sure the privacy is not sacrificed. Also, efficiency and scalability is another key consideration that you need to have, because complex workflow can, if there is no scalability in place, can slow down the response time, and then it actually just can ruin the user experience. So you need to build and optimize the workflow to allocate resource efficiently and also enable that level of scalability for the whole system. Another things that you need to consider is about latency. So user expect immediate result, especially for tasks requiring dynamic interaction. So you need to streamline the processes by even like leveraging strategies such as preloading commonly used data to enable better latency and response for the user. The last but not least is around the evaluation and observability. So without proper evaluation, it's impossible to know how well agents are performing and where they are struggling. So you need to develop metrics like accuracy, response time, and even user satisfaction to assess the performance of the system. And then even like leverage observability tool to monitor the agent behavior and the refine whole workflow. So in terms of use cases, we have like use cases across all these different industries. So from healthcare, scientific research, and content creation. So for example, for customer service, they can handle personalized response to those customers, or even like for scientific research, they can just synthesize massive data set. So as you can see here, there are like a number of different use cases that Agentic RAG system can help to enable modern and adaptable types of response to the user. So future direction and trends that we are seeing. So the future of agentic system and especially agentic RAG system for sure is exciting. So you can think of things like multi-modal retrieval. So that you can use to just seamlessly integrate text, image, and audio to provide holistic answer. Or even with cross-lingual capabilities, this system can operate globally, bridging the language gap and barriers. Even advances in NLP will make the interaction feel increasingly natural. And as AI technology converge, integrated tools like computer vision, speech recognition, and even knowledge graph will unlock even deeper insight. And then the last but not least, as users demand greater accountability, explainability, and transparency, ensuring all these systems enable that level of trustworthy is also another key areas that we are seeing as a future trends and direction of agentic RAG system. All right, now to wrap up, so let's reflect on those key areas that we touch on in this module. So all these agentic RAG systems represent a shift from static information retrieval to dynamic intelligent collaboration. So by leveraging modular architecture, agentic RAG can adapt to the complexity of real-world queries and also offer more context-aware, actionable insight. So in this module, so we covered things like the RAG architecture, its key element, and also some of the popular types of agent that you may see. We also talk about some of the challenges that you may encounter when you are building any of those systems. We had like a hands-on example that showed how you can leverage LangChain framework to build that. And also we talk about the future direction of agentic RAG system. So I hope all these information that is provided in this module were beneficial. And stay tuned as we are going to add more content around the agentic RAG system. Thank you.